Under the base catalyzed reaction condensations, this is the fourth condensation, the order of preference also in the IIT also. First aldol condensation, huge number of questions are coming. Then next Cannizzaro reaction, third one benzoin. This is the fourth reaction, Perkin condensation. There are half a dozen or even 1 dozen reactions are there which are similar to the aldol. So, this is the first similar aldol type of the condensation. If you see the mechanism of the aldol condensation, almost the steps of the aldol condensation are repeated in the Perkin condensation also. So, what is the condition required here? Conditions required is, first one is aromatic aldehydes will condense. Aromatic aldehydes condenses. With 2 alpha hydrogens having aliphatic acid anhydrides. Acid anhydrides. Let us take one example of the aromatic aldehyde, standard example benzaldehyde. Okay, right. Now, what is the example for this one? Minimum 2 alpha hydrogens containing aliphatic acid anhydrides. The simple one is acetic acid anhydride. Let us take. So, acetic acid has 3 alpha hydrogens, right. So, acetic acid anhydride means 2 acetic acids are linked to the 1 common oxygen. This is what anhydride, isn't it? So, the example for the second, that is aromatic aldehyde condenses with this one. What is that condensing molecule? 2 alpha hydrogens containing aliphatic acid anhydride. So, acetic acid anhydride is the simple example. You can have propanoic acid, all that, but on the alpha with reference to the carbonyl, alpha carbon should have a minimum 2. So, I have 3, this side 3, this side 3, okay, well. So, the third condition is in catalyst base required is the same above acid. What is that acid? Aliphatic acid, carboxylic acid, acetic acid. If I take the same acid to sodium salt, the base required is a sodium or potassium salt of above acid. I am simplified above acid, but what is that above acid means? Aliphatic acid containing this alpha hydrogens, I said. So, the corresponding acid means acetic acid I will take. Acetic acid, that to sodium salt you have to take. Why sodium salt or potassium salt also allowed? By why salt means the acid is a weak one actually. Acetic acid is a weak acid whose anion is a strong base, conjugate acid base concept. Just like in the previous case we have taken cyanide minus, not HCN. HCN is acid. So, here also acetic acid is acid, but acetate anion, after removing the proton from weak acid, it will become a strong base. So, the strong base is the acetate anion. Okay. So, the acetate anion is strong base here, base catalyzing in this reaction. What is the base used in Perkin condensation? Straightforward question. RCOO. What RCOO? The same anhydride RCOO, otherwise there will be a jumbling of this the products. So, same acid anhydride what you have taken, the corresponding sodium salt or potassium salt you take, and aromatic aldehyde is condensed. So, let us take one reaction. One benzaldehyde is condensing with now just like aldol we have already know it. I will write 2 hydrogens this side, 1 hydrogen that side of the acetic anhydride, right. So, here you do not have any problem. So, straight away you write down. So, acetic acid 2 hydrogens I have written this side. Now, you make a box mechanism like this. Okay. 2 hydrogens of acetic anhydride, 1 oxygen of the benzaldehyde is undergoing a removal of water. This is called condensation reaction actually. So, between the 2 molecules H2O is lost. So, there comes a double bond between the carbon and carbon. So, this water comes out of the reaction, isn't it? H2O comes. But where that water goes means there is an anhydride. So, on that anhydride this water is attacking and attacks and adds like this, one side H, one side OH. That means this part will become acetic acid, another acetic acid is generated. So, half of the anhydride, that is one acetic acid is condensed with this one. So, the answer comes out as a benzaldehyde condenses with the half of the acetic acid, that is one acetic acid. The other half of the anhydride comes as an acetic acid. So, let us write here itself CH3COOH. So, I have taken anhydride actually, but the anhydride open up into the two acids because of the water. Was it water added by you? No, water is formed in the reaction. In the reaction from the benzaldehyde O, two alpha hydrogens here, water is formed. That water is utilized on the anhydride and it opens into two acids. One acid is added to the benzaldehyde condensed, the other acid is generated as a byproduct. So, this acid is called as water with reference to the carbonyl alpha and beta. So, we call this compound as a alpha beta unsaturated carboxylic acids. So, let me repeat once again, in the aldol condensation we got a alpha beta unsaturated aldehydes or ketones. In the Cannizzaro reaction, one acid and alcohol, that is reduction oxidation. In the benzoin, that is a carbonyl group attached with the hydroxy adjacent, OIN is formed. Now, in this compound the product is alpha beta unsaturated acids will be the answers. Whenever you see alpha beta unsaturated acid, you can see that this acid part is from the anhydride and this is the original carbonyl compound that was added with this anhydride. Half of the acid is there here. This is having a common name also called cinnamic acid. Cinnamic acid. You can name it as a 1, 2, 3, third carbon phenyl, 3 phenyl 2 propenoic acid, or this is called acrylic acid. So, that is 3 phenyl acrylic acid you can say, okay, right. So, that is commonly known as cinnamic acid. So, cinnamic acid is formed in the benzoin Perkin condensation of benzaldehyde with acetic anhydride. But the question as such, benzaldehyde with acetic anhydride, what happens? This question you never expect in the IIT, because that is the example in the all the books it is mentioned. But in one IIT it was asked, benzaldehyde when treated with the not acetic anhydride but propanoic anhydride, propanoic acid anhydride, if it is added, what happens? Then one may try this hydrogens and this O is removed. No, that is wrong. What is the concept here? With reference to the carbonyl hydrogens here, these hydrogens and O will be condensing, not the carbon whichever is closer to here. It is not like that. 2 alpha. Why only alpha? Alpha hydrogen shows hyperconjugation or enolization, tautomerization. Those hydrogens are called acidic hydrogens also. They can only be removed. What is the role here? Means the OH takes away proton, anion is formed. This anion is formed on the second carbon, not on the third carbon. Which proton will be removed? Alpha carbon only, because that is hyperconjugable or acidic. So, anion comes here, that only will attack. So, therefore, while condensing you must be very careful. Whatever the long acid anhydride it is given, but the only alpha hydrogens of 2 hydrogens and the O is removed as a water. So, while writing the answer also you must be very careful. You write the benzene with the CH, put a double bond, okay, double bond, write this carbon first and then it is a, this becomes into acid COOH. So, this, what about this CH3? Let us write as a hanging group. Whatever the long it is there, that will come as a long hanging group. So, what is this compound? Means again cinnamic acid, but a 2-methyl cinnamic acid, just like in aldol condensation. Acetaldehyde will give crotonaldehyde, propanaldehyde will give 2-methyl crotonaldehyde and so on. So, like that it is a 2-methyl cinnamic acid is formed. Okay. Cinnamic acid exists in the geometric isomerism, cis and trans, and stereoselective addition, cis addition, trans addition gives 2 product, different products. For all such things, this will be the one of the starting material. So, it is an important compound. Notice that benzaldehyde condenses with, if it is simple one, the first member, that is acetic anhydride, you will get ordinary cinnamic acid. If 1 carbon extra, this carbon extra carbon will come down. If 2 more carbons are there, let us have a ethyl containing cinnamic acid and so on. The other part is released. This part is released as another acid, that is another byproduct will be there, that is nothing but the propanoic acid. So, different varieties of questions we are getting on this with a slight variation in the anhydride or even starting material also. We have one example, I will tell you. Now, let us take a benzaldehyde containing a OH group here. Do you remember how do you prepare this one? We have one beautiful method. From phenol you can create this one. Phenol using the Reamer-Timer reaction, the phenol with formylation at ortho. However, para also will come, but let us write an ortho isomer and continue the reaction. Acetic anhydride, AC taken twice with O is called acetic anhydride, and its sodium salt Na plus OAC minus, right? These are all short forms. AC stands for CH3CO. CH3CO attached to O, that is nothing but anhydride. So, what happened? The reaction is this acetate group is joined here. So, you will get a compound like this. Okay, a double bond comes here, a C double bond OH will come. Here already one OH is there, like yes, this compound is after this the Perkin condensation you get this answer. But this has got a small extension. If you heat it strongly, because of the proximity of the two OHs without any acid or other medium, just lose the water, and already one water is lost in the condensation. Now, one more water is lost, you get another cycle is formed here. In this cycle there comes one oxygen in the center, and side by there is a carbonyl. It is an ester, it is cyclic ester. A lactone is formed, unsaturation, and 3 double bonds in the as usual benzene, isn't it? This double bond undergoes reactions with bromination, decolorization with permanganate, because it is an aliphatic ene, it shows the ene properties. This is the benzene. These double bonds will not show the decolorization with bromine or permanganate, but this double bond is an aliphatic one, readily decolorizes. So, it has one such type of the function. This is acid ester, internal ester, it is called lactone. A lactone is formed, this is called coumarin. Is a that is a blood thinning or what you call anticoagulating agent it is. Very good that is compound used in the heart patients and all that. So, this compound can be prepared from where? From phenol. Phenol you can also start one step ahead from benzene or chlorobenzene. How do you prepare phenol? Phenol to salicylaldehyde. This is ortho-hydroxy compound is called salicylaldehyde. Salicylaldehyde will give a Perkin condensation to give this alpha beta unsaturated acid. Side by there is the ortho OH. If OH is at para, this type of the elimination will not takes place. But because of the two groups side by side, now elimination of water taking place, and a bicyclo compound is formed with a lactone and a benzene ring together, and it has got some synthetic advantages, and the properties are identified. Therefore, the reaction is also somewhat interesting in this reaction. Mechanism will be on par with the aldol condensation, that is one acetic anhydride loses a proton, will become carbanion first. This carbanion go and attack with the main compound, and you will get a O minus that takes back the H plus and will become hydroxy. That hydroxy is beta to the carbonyl, therefore loses the water. The last water again adds on the anhydride, opens into two acids. Half acid will be to the main compound, half acid is generated as a carboxylic acid. So, in this also the removal of the alpha proton, carbanion formation, attacking on the carbocation and getting back the proton, all that steps in the aldol condensation what we have seen will be there. In this also again rate determining step, what will be the rate determining step means acetic anhydride loses a proton, right? That will be the rate determining step. If OH minus takes away the one proton, the proton removal will become a carbanion, right? So, this carbanion formation will be the rate determining step. This will be the slow step. Once this is formed, a benzaldehyde you have to take and propose that this is going to attack on this one. This is again a fast step. Okay. Then O minus will take back the proton. So, this OH instead of OH, base is used as a acetate anion, right. So, COO minus. So, acetate anion will take the proton, will become into acetic acid. Acetic acid will give back the proton. That proton is given back here. After adding, what you will get? A phenyl CO minus, okay, and then the entire part. This anion will take back this proton, will become the hydroxy. The hydroxy is beta to this one. So, this H and OH will eliminate, that water will be added here. So, the half of the acetic acid joined with the benzaldehyde, other half comes as a byproduct as acetic acid. So, the steps will be very much common like in the aldol condensation. That is why if you really master the aldol condensation, a dozen reactions which are consequent of the aldol condensation like Novi-Nagel condensation and what is that, Reformatsky reaction, Darjan condensation, even Claisen condensation, esters Claisen condensation, all such reactions which are very much closer to this one, that is nitro-aldol condensation, Michael condensation. Several reactions, base catalyzed reactions will follow the same footsteps of the aldol condensation. So, the simplest aldol condensation, if you master it, you can do all the reactions really an excellent fairly. Thank you.